So there are PCs that cost $50,000. But have you seen before a PC that costs $50,000 in a server? Not kidding. $50,000 gives you this 64-core 128-thread CPU, not one, but two RTX A6000s, a generous 1TB of RAM, 7 Gen 4 NVMe SSDs, and this server PC consumes just more than 1600 watts of power. That sounds pretty crazy, but it's not so crazy when I tell you it's going to a super high-end company that specializes in deep learning. Who are they and what do they do? I can't tell you because even I do not know. Okay, so first things first, this is Typhoon Systems custom server rack. You can put an EATX motherboard, a full-size power supply, and there's also enough room for multiple graphics cards. At the front, you can put up to a 360mm AIO. At the front, it has a power button, a reset button, one USB Type-C port, as well as two Type-A ports. Let's begin by removing the lid from the rack. We will also need to remove the top brace to access the bottom. And it will make things slightly easier if you place the cables where you want them to be first. The rack does not come with the motherboard standoffs installed. As we are going to use an EATX motherboard, let's install 10 standoffs. For the motherboard, we are going with the ASUS Pro WRX ATE Sage SE Wi-Fi 2. After you have put the motherboard in the rack, do not forget to put in the motherboard standoff screws. For the CPU, we have the very powerful AMD Threadripper PRO 5995WX, 64 cores and 128 threads, providing all of the lanes for the amount of RAM, the number of PCI devices, as well as the number of SSDs we're going to put inside this server PC. To install this CPU, we're going to use the special screwdriver that came with the box. To release the retention plate, you unscrew in this order: the third screw, do the second screw, and the first. Use your fingers to pry and lift the CPU frame to the vertical position. Remove both the retention cover and socket cover before installing the CPU. Slowly drop the CPU onto the CPU frame, and when you hear a click sound, it means your CPU is secure. Make sure both sides of the frame are latched on the socket, and you can lower the retention plate. Secure the retention plate by tightening the screws in this order: the first screw to the second screw and the third screw. Okay, for storage, 3 of them are 2TB each, and the other 4 are 4TB each. The 3 2TB SSDs will go inside the motherboard, and the other 4 we will show you in the later part of the video. We're going to use all 3 M.2 slots on the motherboard. As these SSDs are longer than your usual SSDs, we can't use a Q latch or M.2 standoffs to hold them down. The only way is to install the socket cover over them. Make sure to remove the thermoplate film before replacing the M.2 socket cover. Okay, for cooling, we have the Typhoon Systems 360mm AIO. This AIO is one of the few cooling solutions that can cover the entire CPU's IHS. Together with 3 Phanteks T30 fans, this AIO will cool the rack as well as cool the 5995WX. The fans function as intake to draw in fresh air to cool the rack. Use the AIO screws to secure the AIO to the front as per usual. Next, we're going to plug in some of the I/O cables like USB 3.0, Type-C and LAN. And we're going to plug in the AIO fans onto the CPU fan header as well as connect the exhaust fans. Instead of using a stock thermal paste that came with the water block, we're going to use the Arctic MX4. For a big CPU like this 5995WX, it will be great if you can spread the thermal paste like butter onto the entire IHS. This gives a more even and better thermal contact to the copper plate on the AIO. Next, let's install the AIO standoffs, the water block, the retention springs, and finally the retention screws. Do not forget to plug in the pump wire. As this motherboard does not have a pump header, we will use the CPU optional fan header. To power this monstrous rack PC, we have the Seasonic HELA 2050 watt power supply. It is an ATX 3.0 power supply and is rated 80 plus platinum. The power supply goes at the top of the rack. As with every other power supply, secure this HELA with the provided screws. Next, plug in one 8-pin for the PCIe slots, a 24-pin cable, and another two 8-pin cables for the CPU. I hope you did not forget the other 4 NVMe SSDs. To put the other 4 SSDs inside this PC, we are going to use the Hyper M.2 card that came with the motherboard. Just a note, these 7 NVMe SSDs are 22-100, so they are slightly longer than your 2280 NVMe SSDs, which actually gave us some problems, which I'll also mention in the later part of the video. Unlike the SSDs on the motherboard, we are able to use the M.2 standoffs and screws to hold the SSDs down. Make sure to install the standoffs at the correct locations based on the length of your SSDs. And also ensure to remove the thermal pad films before replacing the cover on the expansion card. We are going to install the expansion card on the first PCIe slot. Okay, time for the pièce de résistance, the two RTX A6000s from NVIDIA. Both cards have 48 gigs of VRAM each, and they are very suited for deep learning as well as other CUDA applications. The beauty of this motherboard is all PCIe slots are X16. You don't have to worry about losing any bandwidth when you have 2 or more PCIe devices inside a PC like this. We're going to use the next 2 PCIe slots for both GPUs while having an empty slot in between the graphics cards. Okay, time for the last component, the 1TB of RAM. We wanted to make sure that the cables are neat first before we put in the RAM. To install the RAM, press down the tabs on the right. Align the notch on each memory stick with the notch on the RAM slots. There is only one way for the RAM to go in. Push down each stick firmly until you hear clicks on both the left and right sides.
One week later.
Okay, it has been almost a week since we completed this build. There are some things I would like to point out should you want to build something like this or want Typhoon Systems to build you this custom rack PC. First thing, the average startup time for this rack PC is about 5 minutes. In our experience, due to the sheer number of components inside this rack PC will require a much longer startup time than your regular gaming PC. Going through components such as 1TB of RAM, the rack PC will sometimes power cycle 3 times before it can display your operating system on the monitor. Okay, number 2. As we are using 22-100 SSDs, which are longer than 2280 SSDs, it can be difficult to screw the heat shields onto the SSDs and lock them into place. In this ASUS motherboard, the SSD standoffs are soldered onto the motherboard. We are not able to remove the standoffs from the motherboards and use the Q latches that are provided by ASUS. You will have to just leave the SSD there, put the heat shields on top, and screw down the heat shields onto the SSDs. And because of this unique right angle design for M.2 slots 2 and 3, you have to make make sure that both heat shields are connected well so that the screws in the middle that connects both can be screwed down to lock the two heat shields together. After trying for so many times, we gave up and we just decided to change to a new motherboard. And it's not just because of that, we also face some other bigger issues, which will be a story for another time. Number 3, as you can see during the build process, we used the 12-pin high power cable provided by Seasonic to power one of our A6000s. But when we boot to Windows, we found out that Windows only picks up one of the A6000s. We thought it's a driver issue, we removed the driver, reinstalled the driver many times, until we discovered that the issue lies with the 12-pin power cable. The 12-pin power cable does not have the additional 4 pins to fully power the A6000. We have decided to swap to the 12 plus 4-pin power cable provided by NVIDIA. Okay, so one more thing, if you plan to use the Hyper M.2 card like us, make sure to turn on PCIe RAID mode inside the BIOS. This allows the PC to read all 4 NVMe SSDs inside the Hyper M.2 card. Some of you may have this question, why did we go with 2 A6000s instead of 2 4090s? For one, there is more VRAM in an RTX A6000. An RTX A6000 has 48 gigs of VRAM, but a 4090 only has 24 gigs of VRAM. The VRAM in an A6000 are ECC, and you can SLI up to 96 gigs of VRAM with 2 A6000s. I would like to emphasize this rack PC is meant for work, for deep learning, and it's not meant to be used as a gaming PC. You can also picture this. You have a big digital billboard on a shopping mall. If the dimensions of this billboard is 16 by 16 and every panel is 4K, that gives you a total resolution of 64K times 64K. If every 4K image is going to use 24 gigs of VRAM, the two RTX 4090s will definitely not cut it. Okay, benchmark time. This is why you should turn on PBO. The 5995WX performs 21% faster when PBO is on. That's a whopping more than 14,000 points compared to when you run 5995WX at its default settings. And even with PBO on, the 5995WX does not run really hot. It runs at an average of almost 60 degrees with a maximum of 61 degrees. It is still relatively okay compared to when PBO was off. Next, for the GPUs, you can see on V-Ray, one RTX 6000 does almost 6,000 points on the CUDA test and over 7,000 on the RTX benchmark. On the Octane benchmark, it scales pretty well from 1 to 2 RTX 6000. One GPU scores 930 points, 2 GPUs double the score to 1,844 points. Okay, if you're wondering how much power does all of this draw, let's do a little test. Let's first power on Cinebench. Almost 700 watts from the wall. Just a point of note, this is the reading taken from the wall. It consists of all the components, including the CPU, the motherboard, the RAM and everything else on the rack. Now let's power on Optane Bench. 2 GPUs with a max of almost 900 watts. Okay, let's also bring Cinebench. 1400 watts, 1500 watts, more than 1600 watts. Wow! So when you have a rack that runs both Cinebench and Octane Bench, it uses more than 1600 watts. Okay, after all of that, why would you want something like this? For one, if you have a server rack in your office, you can have a few of these stacked up in your server rack and enjoy the huge amount of performance that you can have from a few of these rack PCs. One of them already has so much power. Can you imagine having 5 of these stacked up in your rack? Alternatively, if you do not have a rack, you can possibly still stack a few of these on top of each other and still enjoy an amount of performance from having 1 or 2 or even 3 of these rack PCs. And because it's a server, there is only one way for the air to be channeled. From the front, cold fresh air, to the back, hot exhaust air. So you can be assured that your room will not get as hot, even though it's still a server room and server rooms do get hot. And because it's still a server, it can be really noisy. We have opted to run the 3 T30 fans at full blast because it's used to cool the rack as well as the CPU. So you can hear the amount of noise that can generate. So if you like this awesome $50,000 rack PC, make sure to smash the like button. If you want Typhoon Systems to create a PC like this for you, make sure to check out their website in the description box below. And I'll check back with you in the next video.